Hi guys, this is my new DIY oscilloscope video. What I've got here is, if you notice on my right, I've got a 1-channel 1 megahertz oscilloscope that I sell in my store at www.electroniclessons.com. I have them already built completely, or I've got do-it-yourself kits. The SMD components are completely soldered on. You have to do the rest in assembly on your own. Of course, you get a discount on it for doing it yourself. But it's a great project and great present for those who love electronics. And it's a fantastic little testing device. You can test ultrasonic, you can test audio, you can do all sorts of stuff. You can't really test RF, but you can test the modulated signal, but you can't test the high frequency carrier waves, because it's a 1 megahertz oscilloscope. But it's fantastic, and it's carried around with you. So it comes with a power supply, and it comes with a probe. So right now I'm not sure if it's going to focus properly, but let's just see. I've got it hooked up to my IR circuit. So I'm going to use we're going to test the IR signal coming from a remote control. So right now I've actually been experimenting with it. Bear with me. It's hard to get a good focus on here. I've got it captured right now. You can't see it very well because of the lighting. So please pardon me. Let's just show you how it works pretty much. On the left side we've got the two switches that determine our voltage per division. How it works is you choose between 1 volt or 0.1 volt, and you multiply that by 1, 2, or 5, and that'll be your volts per division. So if I have it on 1 volt times 5, that's 5 volts per division. Or if I have it on 1 volt times 1, that's 1 volt per division. Or if I have it on 0.1 volts times 5, it's 0.5 volts per division. So you get the idea. Pretty easy to use. Right here on the bottom, we can set it up for, I know you can't see it very well, AC coupling, DC coupling, or a frequency, which goes with frequency counter. On the right hand side, we got a series of 9 buttons. OK allows you to hold. It's, if you can see it on the if you can see it, I'm not sure if you can. I'll zoom in on it a bit better in a minute. It allows you to freeze the waveform, so you can analyze it, and you can let go by pressing again. As well, if you want, what you can do is, if you hold OK down for 3 seconds, you get the frequency counter, frequency meter. It's pretty cool. So if you want to change the seconds per division, you press the second per division button, and you press positive or negative, and you can change it. If you want to change your vertical position, you press the V pause button, and you press positive or negative. It'll bring the reference point up or down. So if you want to change, if you have a signal, you pressed OK, you've got it held. Let's actually just do that now as an example. Actually, I'll go through that in a minute. I'll do an example. If you want to change your horizontal position, you want to check along the waveform, you can bring the waveform back and forth and get a better idea of what's going on with the entire waveform that you've frozen. So you can change your mode, your trigger mode. You can change which slope a trigger's on, the positive or negative slope. And it's really wicked little thing. It comes with instructions and everything you need. It's a fantastic little testing device, and I really hope you guys come to my eBay store and have a look, because I've got tons of stuff for hobbyists. So let me just see. If you just give me a minute, I'm going to see if I can get a better view of this thing. Okay, that's pretty good. So right now, so right now we've got I'm not sending an IR signal to my detector, so I'll start sending the signal. Okay, so now what I'm going to do, I'm going to stop, and I'm going to try it one more time, and I'm going to press the hold button so I can freeze the waveform. So if I want to go to horizontal position, change it to see the waveform. You see how I'm moving it to the left? This is what the waveform looks like. The waveform from my remote control. Of course, I can change the time per division. when I'm done. So let's actually unfreeze it, and we'll play with the time per division and the size of the voltage per division. So let's go to time per division. As you can see, much smaller. I've changed the time per division to 0.5 milliseconds per division. Really, it works just like an oscilloscope, but it's a lot less painful in the sense that you don't have to worry about the 500 buttons. It's a perfect little test unit. So let's just keep going. Let's mess with the voltage per division. Okay, so right now we've got it set for 1 volt times 2. So 2 volts per division. We've got roughly a 4 volt signal in the amplitude. So so let's stop it. Let's press hold again. So it rests at about 4 volts. So I'm going to change it to 1 volt times 5. So 5 volts per division. So you see, now we've got about a 5 volt signal. 0 to 5 volts. I mean 0 to 4 volts. We just changed the voltage per division. So we can bring it down to 0.1 volts, but it'll be way off the map. Yeah, so I mean that's for very small signals. For very small signals, you want to use the 0.1 times 1, so it's 1 millivolt per division. You can measure really small signals with it. It really is a fantastic tool. There's so much more to learn about it. There's actually a test signal I can show you if you'd like to test it. And you've got all you need for the DIY. I've got 2 different listings already built. Fantastic little test project. Come on, guys, help me make my store the most badass hobby store out there, okay? Come to my eBay store, www.electroniclessons.com. I really hope that you guys enjoy these and help me grow my store to be the biggest hobby store on eBay. Thank you very much for watching, and I hope to see you on my eBay store. Thanks.